Just to catch you up on where we are with the whole, very little happened since I last made a video down here. I'd packed hardcore around the sump and then went to cut a tree down. That's when I damaged my arm, and obviously then the business with the council started after that, or concluded after that, or ran its course, or escalated, or whatever else. But we're all done now, aren't we? So we've had a failure of the pump system. I don't know if it is definitely the pump that's failed or the control system. The circuitry up top here is all fine, but I haven't been able to check the pumps and such. I think the pump should be running. Maybe it's the wiring to the pump. More likely it's the pump. It's been running for 8 months now, that pump, that little pump down there. It's done pretty well. I'm quite happy with it, but obviously, you know, it was a cheap pump. It's never going to last forever. 7 years would be better than 7 months, but hey, whatever. But anyway, I want to change it all a little bit. I do have a little 24-volt pump back down there, and you can see this small bore plastic pipe. So these are the changes I want to make. We're going to run this system, the pumps and lighting, on 24 volts from my solar panels and battery in the workshop. We're going to modify that. You can just about see the framework that I've got up there. We're going to take those two panels off and put them on the framework, and I've got another 2 panels, so we're going to increase the solar array output and then run armoured cable with 240 volts to the hole as well. Get some circuit protection on that to prevent a repeat of the electric chair incident, and we should have a better setup then. And obviously, yeah, the small bore pipe is okay. Excuse the wind. I've got the front of this new frame welded onto the container. Got a little gasless pig up here, very handy. This is the old frame. It was only ever meant to be temporary anyway, but look, I can see how close to the end it is. Happy to have caught it in. Minimum effort. I got them clamped down. We're not erecting the frame yet. It's just I didn't want them floating away. Laser clamps are made up, pretty simple. End pieces. Just with a square washers. Okay, so here is the finished rack. I've only got 3 panels connected at the minute. I did try putting them all in a string together in series, but it was a little bit too much for the controller, so we'll have to do two pairs, I suppose. It's all right. It's all right. So yeah. Okay, so I've got the 240 volt armoured cable running to the container. Okay, another shitty excuse for not having as many videos as I'd have liked to put out. Yeah, I just had to repair the chamber lid on the. This isn't the shithole. This is the top water inspection chamber, I think. I don't know. Either way, that's the remains of the old one. Fucking, it didn't completely collapse, but I could smell it, you know. And what, it was getting a bit rickety. If I'd have put my foot in the wrong place, I would have got into it. So yeah, this did need doing. Okay, so we're just about down to ring number 10 at the bottom here. That's the last sort of 3 foot of water I need to pump out, and I can't really pump all the way down. I know the pump's not sat at the bottom. It's it's not sat at the bottom of the sump, and the pickup for the pump is 6 inches off the bottom of the pump, so I don't really want to go too much further. I'll get another 6 inches or a foot down, and then we'll have to go down there and put the pump in the sump, and then pump it all the way down, and then have a look at the floats, see what they're doing once the floor's dry, and we can access the floats, I suppose. This pump does have a pickup lower than the original pump, so hopefully I can keep the pump sump level lower than it was previously, and use a couple of better floats that I have. Either way, I'm gonna wait a little bit and get this glorious panel rigged up again for the changes that we're about to make. I might not hook the 240 volt up at the minute. I'll just put the 24 volt in. Okay, so I find for me the absolute best way of avoiding ballsing up wiring of something more complicated than a light switch is by drawing it out how it is laid out in front of you. Yeah. And then sometimes even putting masking tape up, and you can draw the wires on the masking tape or whatever. Don't have to do that here. I don't think it's not overly complicated, but I still had to just sketch it out to get it right in my head. These are the basic positive feedback circuit that we're building for a twin float pump control. Yeah. If you go a long way back when I was still buggering about with bits of ply underground, I built a couple of these and submerged them. So I potted the whole thing in silicon and daisy chained a series of pumps going up the hole, which was mildly successful. I mean, limitedly successful. I mean, by that I mean it worked, but for about 5 minutes. I didn't use big enough relays and and the pumps I used were ever so cheap, which is why I was daisy chaining them in the first place. It was a cost saving attempt, which ultimately failed, but it was fun to try. So this is basically sending power to the top float. You have an upper and a lower float. The idea being that pump only comes on when both floats are submerged, but only goes off again once the bottom float is clear of the water. So you end up pumping an amount of water which you can control, rather than just pumping a little bit and the pump switching off, and then pumping a little bit and the pump switching off, coming on and off too often, whatever. So the idea of this is a feedback circuit where the top float has to be submerged before anything happens, and that sends power to the relay, the switching side of the relay, which switches the pump on. As well as switching the pump on, it sends power back round to the bottom float. So then, even when the top float is no longer made, the bottom float is still made, and that's sort of self-exciting. It's like when you put beer inside me, I become self-exciting, and maintains power to the pump until the bottom float is also broken or not submerged anymore. The bottom float switch is broken. Yeah, you don't want to break the float, do we? No. Anyway, so let's make that happen now that I've got it right in my head. Okay, we're down in the bottom of the hole, folks. Down in the bottom of the hole. So here's the new pump. A little smallish bore pump. Yeah, look at these fasteners, man. They make the body out of stainless, but what is going on there? Oh, maybe it's just filth, and that is stainless. I don't know. Either way, quite conveniently, it's shorter than the first pump I had, and the pickups are lower down, so I will be able to have a greater distance between my floats, which will mean the pump will come on less frequently, and I can keep the water level lower in the sump as well. So that's nice. I can't actually install it properly yet. I'm going to post it into the sump, which is still underwater completely, and we'll pump the water level down so I can see the top of the sump. Then I'll come back down here and try a different set of floats in there, because I have a one-piece assembly with two floats on it, and it's entirely stainless. What I had to do here was make up my own set of floats. They're plastic, probably just as durable, and they're very close together. Either way, let's get the rest of this water out. But that's the new pump anyway. It'll be fun to do a little autopsy on the original pump that served for so long. That was a good little pump that was.
Anyway, let's do it. Like I said, last time I was down here was getting on for a year ago. The day I messed up my arm and what I'd completely forgotten I'd putting the camera down here. I don't even remember doing it now. Actually, to be honest, I expect the data card's probably right. The memory card, sorry. Can't imagine the camera's fared too well though. It's been submerged for quite a while. I don't know. This we've been flooded for a good month or two now. Same with that light. Unfortunately, it never got as high as the second light. But these are 12 volt anyway, and they'll have to come out, be replaced with something 24 volt or at least be wired. But yeah, oh well. It's only a cheap Chinese GoPro. That's one of the positives of just buying these cheap crappy cameras.
Top of the sump is now exposed. Let's work fast whilst we've got a chance before the water comes up again. And another little distraction. Just had to reseal the fuel pump on this fucking Freelander of my mates. Oh look, she's revving so hard the camera's going out of focus. Well, ladies and gentlemen, this is a fucking disaster. I don't know what's happened. Look, my switches obviously work fine because I tested them to see which wires were which, to verify black and black with a lower float and red with the upper float, yeah, and they were functioning correctly at that time, and now they're intermittent and they are switching, but they're doing funny things. So the lower float is seems to want to make in the down position and break in the up position occasionally, but most of the time it's just wandering around in the megohm range. This one isn't doing anything. So I think I've overloaded them. Yeah, they're reed switches, and well, there's a little magnet inside the float. I think. Yeah, that's how they are. Must be. But what? Beginning to suspect. I even redrew my my little diagram to check. And the other weird thing is it's remaining on even with the switches unplugged. So the whole setup appears to be rather flawed. I'm gonna go and scratch my head at the wiring again, see if I can figure out why it's not switching on or off and on. I might put a couple of little switches in the system that are capable of coping with the current of the pump, and the reason for doing that is to verify whether my system should work, and then I can decide whether or not I've somehow overloaded the micro switches, because if that doesn't switch instantly, which solid state relays never do, I mean they take a few milliseconds, don't they? Or in the case of these cheap ones, it's probably more like 200 milliseconds to switch. And so what could happen? I think I could conceivably run the pump through the micro switch for the 200 milliseconds it takes for the cheap Chinese solid state relay to switch on. Does that make sense? In which case it'd definitely overload the fucking trains. There's only a quiet one, don't worry. Overload the micro switches, wouldn't it? Yeah, let me the biggest disaster of all is I've already potted the electrical connection down the back with epoxy. Yeah, so I've used a nice fat old chunk of epoxy to make sure I can't get to the wires on the back of that. Dear, what an idiot. Yeah, this is also quite weird. You can't really see the camera. Maybe you can make out that LED's lit up. Obviously, there's no input voltage. I took that off just to confirm I wasn't going crazy. This relay has latched. It's not a latching relay. It shouldn't be. I'm using DC, and I've read that if you put DC through AC relays, they can latch. That's quite common. I thought this was DC, but it does say 50 to 60 hertz there as well, which confuses me a little. So I do have a slightly smaller capacity relay, which should be alright. I think it's a 30 amp. I think I've got a load of 5, so 30 is sort of the bare minimum. Maybe my load's a little bit higher, whatever. I don't know. It's getting a little bit warm as well. Doesn't really matter. You'll never be running for that long. It's only running right now because I've got quite a bit of water in the bottom. Yeah, fills up pretty quickly. It's been a few days since I last pumped it dry. This video is taking a long time to make because of I unfortunately have to work. Inconsiderate bastards, and also other things keep getting in the way. But let's try that DC relay, because I'm not going to pretend I'm an absolute know-it-all when it comes to electrical components, because I'm really not. Most of it's just guesswork for me, isn't it? Okay. What have we got here? The switch on. Yeah, the switch on works now. So I can just about play a tune, so it'll switch on and off. This is the top float switch. It just comes on and off, on and off. Yeah, and then if I put the look at this, right underneath the most valuable thing I inherited from my father, the wooden mock-up of the original BT76 block terminal connector that he designed. His box of bits and bobs. What have we here? 1 amp die. It's perfect. That'll do. Cheers, old boy. Okay, so these solid state relays, the first one I tried using, which latched because it seems to have been an AC relay that was marked up confusingly, or I don't know what I'm on about. That was a 5 to 25 milliamp switching current, and we were at 24 volt, which is the upper end of the voltage for the switching, which means we're at the lower end of the amperage, around 5 to 8 amp or whatever in it. We're now using the DD220 D25, which has a switching current of 4 to 12 amps, and we'll be at the lower end of that as well. The switches I'm using have a half amp or 500 milliamps, so they should be massively capable of operating these relays. So something did happen to have buggered up both upper and lower switch, and the only thing I can think of is that in the time it took that relay to switch, we were running the pump through not just the lower one but the upper one as well. Yeah, and this can happen if obviously we've got this red one is hot, and when that's switched on, we've got power on this this blue one, which should just be going up to energize the input. But I'm thinking what happened is this sort of backfed the lower one, which was already switched on, and through here to the pump positive. Yeah, and that would have pulled the 7 or 8 amps of the pump through both switches, and we can stop this simply by putting a diode right here. Yeah, and that way the lower switch still gets power when the pump is energized, which can then feed and energize the solid state relay input, but it can't supply the pump for 24 volts. which is, I'm pretty sure, what happened, which is why both our switches are knackered. So we only need one diode, and I've just all I've done on the panel was, have a jumper cable going between pump and that lower one, so I can just, completely no effort whatsoever, just switch that jump cable out with the diode, and we should be golden. The only problem now is I've destroyed the nice switch assembly that I made up, so we're gonna have to go back to the shitty old rusty scummy version. But these switches are still fine. I'll just double check that. Yeah, and I do have spares for these switches, so should be alright. Hey, it's only temporary, no sweat. Let's hope these last long enough for us to get the permanent installation in place. Yeah. Righty ho, folks. So there's my new old float setup, and we've got a little diode in there. We're using that DC solid state relay. See that light? Okay, so we're going lower float up, nothing happens. Upper float down, still on. Lower float down, off. So this is working nicely now. Where have we got to? Yeah, let's leave that pumping for a bit, because we have built up a little bit of water down there. I need to get down there and install the floats. The pump is now in place. I know there's white pipe floating around all over the place now, isn't there? But that's routed along the gantry, if that's what we're calling it. Where's it going? Out into the wilds of Lincolnshire with the wind. Hey! I'll do something about that. I'm not sure what yet, but we probably shouldn't leave it like that. So we're down here at the bottom. Still haven't got all the water out. Pump's working nicely on the floats. Let's put the floats back in the sump, and we can get the truck out of here. Okay, the pump just switched off for the first time. There's still some puddles up here, and there's a lot of water rushing back into the sump already. So that'll just about to activate the second switch again. It's already switched the first one back on, and there's a little bit of water leaking back from the hose. But I mean, that's one of the reasons I wanted to use 10mm, because my non-return valves weren't working too well, and if we used the smaller 10mm pipe, obviously that massively reduces the volume of water in the pipe that's going to leak back in, as opposed to the garden hose pipe which I was using, which is a much bigger diameter in it. Inside is 1/2 inch, I suppose, which is much bigger. But the volume of water it will hold is quite a lot, because from here to the drainage ditch is about 30 foot up here, then about 60 foot over. So I don't know, give a couple of meters for the extra twists and turns, and near enough 100 foot or 30 meters, isn't it, I guess? Anyway, that's it. We're near enough where I am when I left you last. We've got to have a bit of a clean up down here. I think there's leaves and stuff that's got in here. We'll scoop them up before we put any concrete down, but concrete will be the next step. And a bit of concrete will lock this lower ring into place, and I can take the support away and finish cutting the doorway. And then it's the door frame, and then we are tunneling. All right? Okay. Oh, and the pump's just come back on. Okay, it's nice to just be down here and verify that it was working. Yeah, I might actually give it a week of continuous operation just to dry things out a bit down here. I think that'll help. I suppose I can start tidying up while that's happening. This is a homemade tamper just for ramming the limestone. Not that you can tell there's limestone underneath those mouldy leaves, but there's hard packed limestone. It still feels like it's packed nicely. Hey, alright, we'll call it a day there then, folks, and I'll see you all again soon. Take care, bye bye.